Okay, so my name is Ishan, and I'm working as a system administrator in PDC, High Performance Computing Center. So we'll discuss about how we enabled e-science users into clouds using OpenNebula. So this is not a product showcase, and I'm not affiliated with OpenNebula. If some of developer here, you can verify with them. So I'm not for OpenNebula. So this is not a product showcase. So how we use it? There are various ways you can use different platforms. So and you can argue about it how we are actually using it. So today's agenda is that who are the e-science users and some of the projects we work on and challenges we face, and in the last we will talk about federating different cloud centers with EGI Federated Cloud Task Force and definitely QA. PDC is a high performance computing center situated at KTH. So basically we are hosting supercomputers like Gray on the left side, my right side and your left side, and we have other high performance computing centers. So the reason I told you about this, about that the users which we are serving is basically from HPC mindset. And who are the e-science users? Basically, initially we focused on bioinformaticians, and they are currently learning on HPC machines. And that was an issue. Because they think in HPC style that where they get big machine for continuous number of hours, but they want it in elastic way. But that was a challenge for us to change this mindset. But not all, some of the users need bursty peaks, like elasticity. And what we realized that in a long tail, if you see this picture of the long tail, in the angle, in the start you have the big users who are using HPC, and the long users who are not using HPC but they need these bursty peaks. So the set of the users are different. Some of the users they need HPC machines for their scientific problems. And right now, cloud is not in a good shape to host those HPC users, giving them thousands of cores for next like 24 hours a day, 7 days a week. So this is not cloud core. So we had so many talks and debates about this, that who are the cloud using cores, and since they're coming from HPC background, they have this idea that they can get peaks even maintaining the number of thousands cores. So cloud is not for that one. Cloud is for these long tail users who have small sets of problems, but they want peaks for a couple of hours, or 2 hours, 3 hours, but they go like this. If you see the Amazon slides, you see this elastic fashion where you come up and down like this style. And this was a core proposition for us. So we started with a Neon project in 2009. At that time, cloud was just booming up, middlewares, and we found Eucalyptus. And at that time it was 2.0, so we started working on that. And we hosted Eucalyptus environment, and then form a federated with another center. Later on, there was this project finished last year, May 2012, Venus C project, where we collaborated with several centers across Europe. And there we hosted OpenNebula. We moved from Eucalyptus to OpenNebula. And with CDMI, and CDMI developed by Ian Evanson, I found him sitting there accidentally. So he developed CDMI interface for us, and we run that CDMI interface with data management part. OVF part was developed by ENG.IT, Italian group. And they were running OpenNebula, we were running OpenNebula, and another part of our BSC, Barcelona Supercomputing Center, they were running another solution. So we federated, combined this in a way that a user can submit job to any of the centers. This project ended last year, and Sneak Cloud project is basically a Swedish project. This is currently running. We started first with public cloud. Why? Because we want to actually, in a plain word, we want users to become addicted with cloud. And at that time, private cloud computing, was not so mature, honestly speaking. So they need a nice interface, point and click, all this elasticity built in, all this storage built in, and basically scientists are the scientists. Don't treat them as a sysadmin or bash experts. So they need a nice interface with elasticity and all these bells and whistles. And basically we want them to feel comfortable with the cloud. And at that time, public cloud was the only one. So we started with Amazon, we gave a few workshops, we built images for them so that they can be addicted to the cloud, so to changing their minds. And we gave workshops in Oslo, in Bergen, and Sweden, in Uppsala, and in other places. So just to familiarize them with the cloud there. And later on, since we already had a private cloud, we wanted to move them from the public cloud because of the speed. And if you write down one of the reasons why, one of the problems which we are facing, that when we talk about the scientific user, the biggest part is the data. So it's 3 terabyte, 5 terabyte of files. So if you transfer that to S3, and right now in European region, basically there are two problems. And this is not a hypothetical problem, this is a really big problem. One is the privacy. Swedish researcher, and the bioinformatics, they call it bioinformation rather share the brushes than their data. So they rather share the toothbrushes than their data. So they don't want to share data with anyone, especially the results. So, and they don't want to leave the data from the Swedish border. And hosting it in Amazon, that was an issue. And even, if they solve some of the privacy issue, then the uploading and downloading of the data is very cumbersome because of the speed. So we face this issue, and so we plan to move back those users with their fancy Amazon Cloud Management Console back to the private cloud with few challenges. And these are the two challenges. Basically, what we face is I am myself a sys administrator, so I face this issue. One kind is non-technical issue, and you will see later it's about changing hearts and minds. And another is a technical issue, which is rather easier. What are the non-technical issues? Whenever you talk about cloud, there suddenly come up the notion of security, that is not secure. So my background is I started working at PDC from grid side, grid computing, and I have a master's degree from KTH as well. So basically coming from the grid side, I faced this issue, and when we were deploying the cloud, and both from the user side and both from other people's, we faced this. Whenever we talk about cloud, they say, okay, it's not secure. Why you are doing that? And like I told you before that, the users, they were living in HPC world. So they were thinking cloud as an HPC style. And because it is really hard to digest elasticity, for them to tell them that, okay, you can define the parameters when to launch more instances and cut down instances, it's very hard to tell them. It's hard to tell them to think in this way. So we face an issue that when one of the users run a big instance on Amazon, and even they keep running into unification, they forgot to terminate because they were not tuned in Elastic to use the instances in an Elastic fashion. They were thinking that they just got an instance, and they configure it, and then they keep running it on the vacations. And on-demand and self-provisioning, these are also problems, non-technical problems. And the last one is very funny because when you host a private cloud, it has to live with other people's. So it has to live with other infrastructure, and then you live with other sysadmins. So usually sysadmins are conservative, and when you talk about cloud, they say, "What do you mean about that?" And then it's suspicious. So to say, but I know you people not like that if you're sysadmins, otherwise you're in the wrong room here. So they will face this problem. So you have to align your private cloud with other infrastructure groups. And this was a non-technical issue. There is no technical solution for that, except that you convince them or come from top. Okay, so, and this one also very funny that some sysadmin was thinking that when you give the power to the user they're not coming back to you. So for example, let's take a use case when a user wants a virtual machine. before cloud, they have to ask sysadmin, please create a virtual machine for me. And since sysadmin is always busy, so he said, okay, I will do this, and then it takes time, maybe hours, maybe days, or maybe weeks. Imagine if the user say, I need 5 virtual machines, and they get it after 1 week, and they say, okay, I need it only for 1 hour. And after next day, they say, I need 10 more, but I need those 10 machines only for 2 hours. I mean, sysadmin, beside all this automatic installation of VMs, it takes time for them to create VMs. And when they see this, that when you enable cloud to the user, you give this self-provisioning to the users, and they were afraid that there will be more jobless sysadmins. I took this picture because on this one of the driver, he is managing all things to himself, and other is a pilot. Both are the same role. But the pilot is more elastic, more automatic things. They have different styles. So it's not about jobless thinking. So you have to tune yourself, you have to choose yourself what kind of styles you want to prepare. You want either to control everything so that users come back before you so you feel comfortable and feel secure about your position, or you want to focus on more strategic issues, more big issues, and leave the user aside so that they can be flexible in this way. Not a technical issue. When we host the e-science users, first thing comes up about the network latency. So in network latency, we solve it by combining with InfiniBand and then multiple NICs. So, and there is, like I said before, there can be various ways to solve this issue. This is the way we solve it, and there can be, this can be extended or improved later. So we have separate network cards for application data and separate network card for controller. The storage thing, we solve it with different image repository on different RAID. And for application data, we supplied an EBS style kind of storage solution with on separate RAID solution. And for combining and for others, we also have the CDMI. Public APIs, since it is now the V4 APIs is like commodities, not so many. So we limit the users to if they form cluster. So we ask them to only have one public API on their master, and then rest of the 20-25 nodes as a slaves should not get public IPs. Understand? But this is the one of the issue that we cannot solve. It's not easy to solve because we don't have public IPs. But users always come up more. And all of this, we have the notion of infinite in a cloud with italics and with inverted commas. But basically, down the iron racks, it's limited to this physical boundary. So it cannot either you get more hardware or either you go hardware. So you can attach private cloud, I think any of them, OpenNebula, OpenStack, or you could have this, to EC2 interfaces. But their user has to think about that, because when they have to do this proper risk management, that what they want to run on the private cloud in the Swedish border or in a country border, or what they want to host outside, they have to do this risk analysis themselves or combined with cloud management who's providing. And the sharing of images. But be careful here, because we face this issue when users share the image, but they forgot to clean this etc SSH authorized keys file. So it's got bigger and bigger, but that was not an issue. But those people whose public keys are there, when this VM image launched by another user, if it is not properly cleaned, those users can log in to those machines. So using the hooking mechanism of OpenNebula, you can clean up, before the shutdown, you can clean up the image. This is how we do it today. And when we're talking about the users, we say, okay, how they use it. So Sunstone, we configured it this year, and previously most of the users were using command line interface of OpenNebula. It was very easy, but we configured it, but we give them this, we download it and change the command line interfaces so that user don't get the full command line interface. the one which they need. And later, some of the users, if you talk about the eScience user, they already have their application. Some of the applications are open source. Some of the eScience users hired a master student to code a new application, and they are coding the application in some IDE. So they want an SDK style access to cloud. And this problem which we see, agile developer versus static administrator. So on that side, whenever you talk, let's take a case that you are a software developer, and from your code you want to run your code on cloud, and then you develop your code, but then you go outside of your IDE or say to system administrator to launch more VMs. But even if it is a cloud, you have to go outside of your IDE and go to Sunstone or use command bash style to launch VMs. We solved it, and that's the bottleneck. We solved it using SDK, where now users can launch the virtual machines instances right from their own code, so they don't have to leave IDE where they are programming. So since we use the Java one, and then there's some of the examples. Spark, we extended the Spark here. Spark is a MapReduce kind of, and Hadoop, and Spark runs on memory kind of thing. So basically, in this way, they have no dependency on even on cloud admin, and they don't have to leave, because this code last year, in Las Vegas, CTO of Amazon, they say this. Whenever we talk about this, another funny thing is that whenever we talk about cloud to others people, they say, okay, cloud is not just not. I mean, it's only virtual management system. It's just a bunch of virtual machines running here and there. It's just like VM management system. Understand? So they think that the cloud is just only VM management service. So CTO of Amazon, he said that think compute and storage as an object. You create, you destroy, you operate as whenever you want and however you like it. So using the SDK, we were able to get it, this idea. One more technical issue is security. We managed to get it through VLANs, through bridge firewalls, and the network auditing tools. We forced to use the traditional ones. And for example, and this last one is a question that what if one of the legitimate user install a legal software, a Tomcat for example, and configured it wrongly, so that its manager panel has default password, and any other hacker who has access to the manager panel deployed a botnet or any bomb. How to stop that one? Since VM introspection or VM auditing is limited technically, plus also by privacy rules, it's very hard to, you can only manage it through a black box, or either you have a firewall outside, you just monitor the traffic, but you are managing it on the network level. It's very hard to see the running processing and what the user installed and all the vulnerability management things in the VM. So this is the real problem which we faced. And we got blocked by our KTH IIT because one of the legitimate users did this, and he was not aware of that. And it was the configure bomb was required. And anyhow, so this was the issue which is still in question. There can be various solutions for that one. If you have one, please convey. It's federation now. So when we talk about federation, we are actually part of EGI Cloud Federation Task Force. EGI is a successor of EGE, Enable Grid for eScience, and many of you already know that. You can read more about that Fed Cloud Task Force. The task force has a duty is actually federating different centers across the world. So when you talk about federation, these are the areas. VM management. Be able to get the federation of VM management through using OCCI interface. And every centers, I look at a list here, they were running different middlewares, cloud middlewares. I'm using the terminology of grid that cloud middlewares. Some of them running OpenNebula, some of them running OpenStack, some of them running W nodes, and you will get a list here. But they all of them provided OCCI interface in front of them, in front of their middleware. So OCCI is part of our federation when we talk about VM. Data management federation, we got it through CDN proxy. Information system, to get the information, we use the same old glue-to schema with using LDAP server. Accounting, again, this is cloud usage record, but basically it is using the same usage record from grid world. Monitoring, we did it with values with some of the cloud probes, so the VM is able to deploy, and there are some tests. And federated AI, this is a very, whenever you talk about the federation, one of the biggest issues is that how you federate users. Since this group is also from the grid side, so we were thinking in a grid, because we were trying to reuse everything, we spent time, money on the grid. So we get it federation by H.509, because H.509 is heavily used in grid world, and support the virtual network organization. So we built a VO to get this federation thing. To share the images, so that when a user launches a VM on any of the resource provider, you will see the list next slide, where to get this list of the image. So we use Status Lab Marketplace. I noticed that OpenNebula also launched one of the Marketplace solutions, but we were using Status Lab in Marketplace software to share the image. So federation part, this is just a diagram. OCCI, CDMI, glue schema, UR, and H.509. So these are the centers. 60 individuals and 23 institutions, and more are coming up, more are joining. And we have KDH, we have SARA, we have SDFC UK, we have GRNet, INFN, and several other CypherNet. And they were running, 7 of them running OpenNebula. This slide actually is from September. So there is now more resource providers running up. So 7 of them were running OpenNebula. 3 of them running Status Lab, which is OpenNebula, but let's see more tweaks. 3 of them running OpenStack, 1 OpenX, and 1 W nodes. So in total we have 15 resource providers, 7 technology providers, 5 user communities. User communities are the ones who are actually testing that. So these are use cases we were running. So they were all, no matter if you are running OpenNebula or Status Lab, as long as you provide OCCI interface in front of that, I mean you can federate with it. These are the components for AI using H.509. For VM management, we using OCCI 1.1, and it's called. Currently, we are using Rocky, it's Ruby-based OCCI implementation developed by GWDG, Florian. VM sharing by Marketplace, and information sharing by Glue2, LDAP, and the resource providers in between. And each resource provider has to run all this. He has to run information system, data management, accounting, monitoring, not monitoring. He has to accept monitoring props into his resource provider. And accounting records will push to central accounting server. So this is and the client can access using the same client without changing anything, as long as he has access to all the resource providers through this centralized federated authentication service. So he can access and launch virtual machine to any of the resource providers. So he can launch virtual machines into any of the 15 resource providers without changing anything if he has access to those resource providers. This is where we federated across Europe to different centers. This was this was the same thing but different layout. So, and these are the issues which we are facing now. And these are not solved yet. Our users, they want, because since we already addicted them to Amazon, so they first go to Amazon and then whenever they see a new service, they come back to us, they say, okay, this is a nice service, can we have that? For example, this simple workflow kind of service is very meaningful for them. We needed a private cloud, and I could not get it using OpenNebula yet. If you have any solution, please tell me. There was one Cloud Era or something, but that project is like stopped. is orchestration service. Really, the user wants a cloud watch kind of thing of Amazon in private cloud. They want to define parameters based on RAM, based on process, based on time. So for example, they should specify that in the morning between 9 and the evening between 9 to 5, they need these number of instances, but when they go back home, this instance should be given back. This is not, we haven't implemented that in our cloud because I could not find solution to do that. A really good orchestration service for private cloud. And the third one is auditing VM from inside. Because of this problem which we face, and there can be other problems where we need to audit or introspect the VM, running VM. Either with number of processes it is consuming, we need to audit the VM. But the question is that should we do this? Because each country has their own privacy regulation, and the student is very strict about that. We cannot do this in Sweden legally. So, and they also need a bare metal. They want to move, just giving them virtual machines. They want to move from IaaS to app style to get an application running. Some of the users comes up and they say we want to configure Spark. And there we have to work with them. We have to prepare images for them. We have to prepare cluster for them, even it's cloud, but they don't know how to do this. So they need prepared applications like Galaxy, like MapReduce or Spark on the fly. So they need this kind of this. They want to move from infrastructure as a service, little bit up, not platform as a service, not software as a service, little bit in between that. I call it application as a service. So it's not a platform as a service, it's not a software as a service, it's like an application as a service. So it comes in between. So they want to little bit move up. Some of the users, they know how to configure and install software on virtual machines. Some of the users, they don't know. So they need bare metal install full application stack. And furthermore, when we talk about these platform things, the platform security is even harder than infrastructure security. Because in platform security is very hard. For example, how do you check that if a user accessing a particular database, should he able to access this file system or not? Because in infrastructure service is very easy to get a list of processes. If it is listing on the port, you can run the nmap if there is running. If there is something strange ports are running, you can notify the users. But in platform security, it's very hard to have this artificial intelligence, or you should imply machine learning techniques here to know that if this user is allowed to access this database or this table or at this time. So this is the problem. Platform security is harder in our point of view. So this is the last slide, I think so. So thank you very much, and this is my email address. You can not grab me, but you can contact me later after this talk, or if you have any question, you can send me an email, any question or any suggestion, please. Sorry?
How did your HPC user react to the use of virtualized machine?
How your HPC users
react to the use of virtualized machine? If they feel a loss of performance due to virtualization?
No, not really. But those HPC users, honestly speaking, they don't want to go to cloud. They want big machines. Since you already hosting HPC servers, so they would rather go to gray machines with thousands of cores and come back to us. They want to go to